get as far. Yesterday we talked about everything pertaining to domain and range and function and one-to-one as it pertains to a graph. Okay? Today we're going to move from a graph to tables. Tables. Okay? So let's go to example 2, and we're talking about a function. Okay? A function is, please write this down, the relationship from the domain. What's the domain again? Anybody? What's the domain? Your x values. Maybe you put that above. The relationship from the x values or your domain to the range, which is your y values. And for a function, we cannot have repeated x values. We cannot have repeated x values because that relationship from the domain to the range is going from one value from the x to one value of the y. So the function is the relationship from the domain to the range, and we cannot have repeated x values. Means you can't have the same number in the x column. All right? For one-to-one, first, it must be a function. So it has to be a function before it can be one-to-one. And then second, okay, every element of the range matches with only one element of the domain. Okay? So it's kind of going backwards. And what does that mean? It means you have no repeated y values. Okay? With only one element of the domain. So first of all, it has to be a function. And then second, every element of that y value, those range, has and matches up with only one element of the domain. And what does that mean? You don't have any repeated y values. Okay? So we're going to look at these tables below. These are our tables. And we have the x value, and that's called the domain. And we have the y values, and that is my range. Okay, so we have to determine, is it a, is that what I want? Yes. Is it a function? And then if it's a function, is it a one-to-one function? Come on. Or is it neither? So is it a function? If it's a function, is it one-to-one or is it neither? Okay? All right, let's take a look. So, first of all, is it a function? Look at your domain. You have 1 going to 6. You have 0 going to 2. And what these are like ordered pairs. So 1 goes to 6, 0 goes to 2, 8 goes to -3, 9 goes to -7, 1 goes to 4. So the problem here is you have 1 going to 6 and you have 1 going to -4. You can't have that x value go to two different things. So that means it is not a function. Not a function. Does everybody understand that? Okay. Now, if it's not a function, we don't even really have to check for the one-to-one, but we already know that means it's not a one-to-one function either. Okay? So this would be in the category, I guess, I could have just put neither. Okay? Neither. Let's take a look at the table to the right. So here we have -6 goes to 4. 5 goes to 1, 4 goes to 3, -5 goes to -6, 1 goes to -12. Do I have any repeated x values? Okay, so that means it is a function, and then because it's a function, I can then go on and say, is it one-to-one? So now I look at my y values, which I should write up here. Domain and range. My y values are the range. 4 goes back to -6. 1 corresponds with 5. 3 corresponds with 4. -6 corresponds with -5. -12 corresponds with 1. Do I have any repeats in the range? No. So that means yes, it is a one-to-one function. Okay? So it is both of those. All right, so let's look at the next table, domain and range. Take a look at your x values. Is that a function? Survey says, I see some going like this and some going like this. Do I have any repeats in the x values? I don't. So does that mean it's a function? Yes, you don't want repeats. So this is a function. And then do I have, do I have any repeats in the y values? Yeah, you got 2 going back to -2, and 2 goes back here to 7. So it is not a one-to-one function. Does everybody see the difference? You got to look for those repeats. And they're not necessarily always in order either. All right, the last one. Tell me, function, and is it then one-to-one? Is it a function? Is it one-to-one? What do you think? Function? Yes. And because it's a function, now I can go on. Is it one-to-one? No, we got all these 5s matching up. So it is not a one-to-one function. Any questions on how to determine if it's a function or a one-to-one function for tables? Yes? On one of the number lines? You mean here on the tables? Yes. If there is a repeated number in the x's, then it's not a function. And if it's a repeated number in the y's, then it's not one-to-one. Yep, you got it. You got it. All right, are we ready to turn the page? Okay, so here we have some columns like tables, okay? It says the table shows the number of medals the United States won at 5 Olympic Summer Games. So they give us the years, they give us number of gold medals, number of silver medals, number of bronze medals. Okay, directions say, analyze the table, determine if gold and silver medals are functions, if they're one-to-one or neither. Terrence, are you with me? Okay, let's keep your head up here. So, gold and silver, are they functions, one-to-one or neither? what do you think my x value is going to be here? What is my domain? Take a guess. What's your domain? Is it the year? Is it the number of gold medals, number of silver, or number of bronze? It's the year. Somebody said it. Yes, it's the year. So this is going to be your domain. You might write that up somewhere. And what's going to be my range? For the first one, it's going to be the number of gold medals. Okay? So again, this is like an ordered pair. You're going to say 2016, and then you're going to say 46. Okay? So as I'm looking at the year, I'm going to say the year here, and then I'm going to say the number of gold medals. First of all, is that a function? So as you check down here, you're like 2016, 12, 2008, 2004, 2000. Is that a function? Yeah, because each of those is representing a different Olympic year. So it is a function. Now, because it's a function, I can go on and see, is it a one-to-one function? Well, let's see. I got 46, 46, 36, 36, and 37. Is that one-to-one? No, it is not one-to-one because you have 46 going back to this year and 46 going back to a different year. So not one-to-one. Okay? Now it says determine if the silver medals are functions. So again, you're going to have your year, and this is going to be a second set of the range with the silver medals. Okay, so this is my second range. Because you can have different kinds of medals, and we could do a third range with the bronze, and so on and so forth. So back again, first of all, if I look at the year, is it a function to go from the year to the number of silver medals? Is that a yes or a no? Yes, it is a function. And then to go to the silver medals, check and see, do I have any repeated numbers? 37, 29, 38, 39, 24. You do not, so yes, it is a one-to-one function. Okay? Questions on that? All right. So now you can look at these things. You know how to find ranges and domains of graphs and tables, and you can determine if they are functions or if they are one-to-one. All right, the next part. Functions can be discrete, they can be continuous, or neither. All right, real-world situations where only some numbers are reasonable are modeled by discrete functions. Situations where all real numbers are reasonable are modeled by continuous. Okay? So I would say let's underline this part right here. It says a continuous function is graphed with a line or unbroken curve. Might underline that. All right? A function that is not discontinuous that is not continuous is discontinuous. Well, that makes sense. And finally, a discrete function is a discontinuous function in which the points are not connected. All right, so here are my different types. First up, a continuous function. So draw very quickly a coordinate plane, right, with your x and your y here. And here's a continuous function. It is going to be a line, and that's continuous because it goes on forever. Okay? Or it could also be a curvy line, but remember, you have to be able to use that vertical line test. So you can't have it with a vertical line test going in two places. So both of these show continuous functions. All right? Now, in the second one, let's show a discontinuous function. It is not continuous. It is going to have a hole somewhere. That might look something like this. That means in that spot, there is no answer. There is no point, no answer. There's a break. That's discontinuous. Okay? And it could also look like this again, but you have another break. And finally, my favorite, the discrete. D with discrete. You do your X and Y coordinate plane. And discrete is going to look like dots. And this is the real world one that they talk about. Okay? So they actually are just dots. Because in the real world, you're often looking for specific answers. Okay? So continuous, no break in the line. Discontinuous, there is a break, there is a hole, and discrete, dots. So let's look at example 4. Look at the functions, determine whether they are discrete, continuous, or neither. So that first one, take a look at this graph. Is that continuous, discontinuous, or discrete? Nope. Nope. Continuous, yeah, it's goes on forever. It's a line, it's got the arrows, so that is continuous. It says because it's a curve with no breaks or discontinuities. Discontinuities. Because you can assume the function continues forever, the domain and range are both all real numbers. Okay? Let's turn the page, look up at the top. Take a look at graph B. Is that continuous, discontinuous, or discrete? What is it? No, not continuous. It's got this nice little hole right here, right? Discontinuous. Discontinuous. It says there are continuous sections, but there's a break at 2, 1. It's not defined for where x is equal to 2, and it's not defined where y is equal to 1. And the last one is discrete. Yes. Discrete. They are specific little dots. And the domain is the x values, remember. And what else do you notice? They are all in order. Okay? From smallest to greatest. And these are my range, which are my y values. Smallest to greatest. Okay? Whew. All right. There we go. Any questions about any of the notes that we did for today? Yes. Yes, it doesn't look very good. Smallest, SM, smallest to greatest. Because when you look at this, you might say, Oh, -3, -3. Is there a point that's -3, -3? Let me just look. So that's 3 to the left. 1, 2, 3. 3 down. 1, 2, 3. There is not a point there. So it's not that they match up necessarily. It's just in order from smallest to greatest. Okay? That's what I'm saying there. All right. So now take out your homework. I gave you a homework packet yesterday.